Welcome to Lesson 2.2. Today we're going to talk about some fundamental chemical laws. First chemist we're going to talk about is Antoine Lavoisier. We finished up last time discussing phlogiston and dephlogisticated air. Antoine Lavoisier took it upon himself to actually explain the true nature of combustion, and Antoine Lavoisier is actually considered to be the father of chemistry because he basically said without taking measurements then you can't do chemistry. One of the laws that Lavoisier looked at is the law of conservation of mass. We'll talk about that a lot more in great detail in the future. But the law of conservation of mass says that mass can be neither created nor destroyed in a chemical reaction. He actually, in order to explain the true nature of combustion, he did some quantitative experiments. And in the time that Lavoisier did these experiments, obviously you know as well as I do that you can't see the gases in the air around you, and so to do experiments involving oxygen was difficult even in especially in his time, and so he did a lot of quantitative experiments and was able to show combustion. He also delved into a little biology and discovered that life was also supported by processes involving oxygen, so combustion of materials, and then cellular respiration as well. Another scientist, Joseph Proust, came up with what we call the law of definite proportion. But the law of definite proportion says a given compound always contains exactly the same proportion of elements by mass. So, for example, let's look at water. Hydrogen has a mass of 1. Oxygen has a mass of 16. There are 2 hydrogens in water, so H2O. So the hydrogens would have a total mass of 2 in the compound, and the oxygen would have 16. By the law of definite proportion, anytime you have water, that means that you have the same proportion of elements by mass. So anytime you have water, you're always going to have a 1:8 ratio of hydrogen to water in that compound, because its formula is H2O, 2 grams to 16 grams, 1:8. So that's the law of definite proportion, and that's if you're talking about a specific compound. When John Dalton started looking at different compounds, he came up with the law of multiple proportions. And what he is talking about in the law of multiple proportions is he is talking about elements that can combine to form multiple types of compounds. An example that's used often when you talk about the law of multiple proportions are the numerous compounds that nitrogen and oxygen can make. So, when 2 elements form a series of compounds, the ratios of the masses of the second element combined with 1 gram of the first element can always be reduced to small whole numbers. And so what he was alluding to was that you can, when you calculate these multiple proportions, you're always going to get ratios of atoms. So let's look at an example. Here is some data collected. These are nitrogen and oxygen compounds, and every time it's 1 gram of oxygen, and we're going to look at how these data relate to one another. So compound A, you have 1.75 grams of nitrogen to 1 gram of oxygen. Compound B, you have 0.8750, and compound C, you have 0.4375 grams. So for the law of multiple proportions to hold, the ratios combining with 1 gram of oxygen in each pair should be small whole numbers. So if you're comparing compound A to compound B, and just the mass ratios, you get 2 to 1. Compound B to C, you get 2 to 1. And then if you compare A to C, you get 4 to 1. So that supports the law of multiple proportions. So that means in compound A, you would have 4 atoms of nitrogen to every atom of oxygen. In compound B, you would have 2 atoms of nitrogen to every atom of oxygen. And in compound C, it would be a 1-to-1 ratio. So let's look at this last slide and tie some of this back to what we talked about. So according to the law of definite proportion, so this was Proust's law, let's see which of these applies. If the same two elements form two different compounds, they do so in the same ratio. Okay, well that's not definite proportions, because the law of definite proportions, you're talking about one compound. Let's look at B. It is not possible for the same two elements to form more than one compound. That's not even talked about in the law of definite proportions, and we know by the law of multiple proportions that's not correct. Answer choice C, the ratio of the masses of the elements in a compound is always the same. That is the law of definite proportions, so we'll choose C. And then if you go on and look at D, that's basically talking about the law of conservation of mass. Okay, so that's it for lesson 2.2. We will continue with John Dalton in lesson 2.3.